One command, one microsecond. No lock, no wait, no thread fighting for control. Redis runs on a single thread, yet it outperforms multi-threaded databases running on 64 cores. Think of it as one master chef, alone in the kitchen, with every ingredient already chopped and sitting on the counter. That's the secret nobody explains, right? This isn't a toy. Twitter renders home timelines for 300 million users in under 1 millisecond, straight from Redis. GitHub checks rate limits on 10 billion API calls a day with one atomic command. Stack Overflow runs its entire site on 9 web servers and just 2 Redis instances. Here's the villain. Traditional databases treat every read like a trip to a walk-in freezer. Client asks, server parses the query, then walks to disk, waits for the platter or SSD controller, and walks back. Milliseconds turn into tens of milliseconds. That walk to the freezer melts your API latency budget. The obvious fix? Add more threads, more cores, more locks to keep them from stepping on each other. But now every cook needs to grab a shared spice rack before touching data. Threads block, contention spikes. You've built a kitchen where 5 chefs fight over one knife. Here's what nobody tells you. Single-threaded is the performance hack. Redis skips locks entirely because only one command runs at a time. No mutex, no context switch, no cache line ping-pong between cores. Removing concurrency didn't slow Redis down. It's exactly why Redis hits 1 million ops per second on one core. The trick engineers use is an event loop, the same pattern powering Node.js. One loop, using Linux's epoll, watches thousands of client sockets at once. A command arrives, the loop grabs it, runs it instantly, moves to the next. No thread hands off the ingredient, the chef never leaves the counter. Remember the single chef? Every Redis command follows one path. Read socket, parse it, look up the key, run the operation, write the response. No detours, no waiting on another cook. That single, predictable path, not raw CPU power, is why Redis responds in microseconds instead of milliseconds. But speed alone doesn't explain Redis's popularity. Redis isn't a dumb key-value cache, it's a data structure server. Strings for counters, lists for queues, hashes for user profiles, sets for tags, sorted sets for leaderboards. Every structure ships with O1 or O log n operations. No full table scans ever. Take a gaming leaderboard. One command, zinc or by, atomically bumps a player's score and keeps everyone ranked automatically. No select, no order by, no index rebuild. The sorted set is always sorted because it's built on a skip list under the hood, not bolted on after the fact. Redis also obsesses over memory. Small hashes and lists use a packed format called list pack. No pointers, just sequential bytes. A 10-field hash shrinks from 800 bytes to roughly 200. That's why 64 gigabytes of RAM can hold 500 million simple keys without breaking a sweat. Zoom into one command end-to-end. Client sends zinc or by over TCP using the recipe protocol. The event loop reads it, parses 4 arguments, looks up the sorted set, updates the skip list and hash table together, then writes the new score back. Total time on modern hardware, about 1 microsecond. But wait, Redis lives in RAM. Unplug the server and everything vanishes. That's a serious problem if your leaderboard, your session tokens, or your rate limit counters are the only copy in memory. The chef's countertop burns down, and every prepped ingredient is gone with it. The fix is RDB, periodic snapshots of the entire dataset to disk. BGSave forks the process. The child writes the snapshot while the parent keeps serving traffic. Fast startup, compact files. The catch, anything written between snapshots disappears if the server crashes right before the next save. For tighter durability, Redis offers AOF, an append-only log of every write command. Restart and Redis replays the log. Slower restart, bigger files, but configurable to lose at most 1 second of data. Most production teams run both. RDB for fast recovery, AOF for durability. In your next interview, say exactly this. We run append-only, yes, with append fsync every sec. That caps data loss at 1 second with minimal performance hit. That sentence tells the interviewer you understand the trade-off, not just the buzzword. Redis also routes real-time messages. Publish sends a message to a channel. Every subscribed client gets it instantly. Slack uses exactly this to route messages between servers. It's simple, fast, fire and forget, like shouting an order across the kitchen instead of writing it on a ticket. But shouting has a flaw. If a cook stepped away, the order is lost forever. Redis PubSub gives no persistence, no acknowledgement, no replay. For anything that must be delivered, orders, events, payments, fire and forget is a liability, not a feature. Redis Streams fixes this. An append-only log with consumer groups, like a lightweight Kafka living in memory. Multiple consumers split the work, acknowledge each message, and unacknowledged ones sit in a pending list until retried. Now the kitchen ticket never disappears until someone signs off on it. Great, but one Redis instance still has one CPU core and one memory ceiling. Twitter doesn't run one Redis, they run thousands of nodes globally. When your dataset outgrows one machine, you need to split it. That's where Redis cluster walks in. Redis cluster splits the key space into 16,384 hash slots spread across nodes. Each key slot comes from CRC16 of the key modulo 16384. A 3-node cluster might own roughly 5,000 slots each. Every node knows the full map, so a client can ask any node and get routed correctly. One catch: multi-key operations must land on the same slot. That's why engineers use hashtags. Writing user40 profile and user settings forces both onto identical slots. Skip this, and Redis cluster simply refuses the cross-slot command. A small syntax trick with huge scaling consequences. Back to Twitter, each home timeline is one sorted set, timeline user ID scored by tweet timestamp. zRevRange returns your 20 newest tweets in log n time. Total round trip, under 5 milliseconds. The SQL join equivalent, joining follows, tweets, and users, takes 200 to 500 milliseconds. GitHub's rate limiter is even simpler, 1 atomic INCR per API key per minute bucket. Cross 5,000 requests in a minute, and the next call gets a 429. Increment, compare, expire, all in one round trip atomically 10 billion times a day. That's how Stack Overflow runs its entire site on 9 web servers and just 2 Redis instances. 99% of reads never touch SQL Server at all. Redis absorbs the traffic a fleet of database replicas would otherwise need to handle. For your next system design interview, say this: Redis is fast because it's single-threaded with no lock overhead, uses purpose-built data structures instead of generic tables, and keeps everything in RAM. One sentence covers concurrency, data modeling, and storage. Zoom out, and the whole story is one contrast. Relational databases optimize for durability and flexibility. Redis optimizes for speed and predictability. Neither wins outright. Production systems run both, Postgres as the source of truth, Redis as the counter that never makes you wait. One chef, one countertop, everything pre-chopped and within reach. That's still Redis, whether it's serving Twitter's timelines or GitHub's rate limits. Understand that, and you'll never fumble a Redis question again. Subscribe for the next system design breakdown.